Now that we've learned a little bit about matter, we're going to learn how do you classify matter. Ugh, but you can't do that unless you know what it is to classify. So to do that, we're going to use this example of some food, and we're going to classify this food. So I would say, okay, oh, vegetables. Vegetables would be classifying food. And so these would be vegetables, and some over here, vegetables. Oh, and then we've got some grains or breads right over here with the bagels and the pasta and the pasta. That would be another classification. Dairy products could be a classification of food. We got cheese, milk, right? Fruits could be a classification. Meats could be a classification. I think you guys are probably understanding how this works. So basically, classifying is you're just putting things in groups, and the groups are that way because they have shared characteristics. Okay, so we can classify matter, we can group matter, but wait, what's matter again? Oh man. Matter is anything that has mass and takes up space. Anything that has mass and volume, okay? So when we're classifying matter, basically we're just putting it into categories, and there are two main categories, substances and mixtures. So we're going to start with substances. Substances all have just one kind of matter in them, and they look the same throughout. That's what uniform properties means, this uniform properties. That means it looks the same throughout. So let me give you an example. Things like aluminum or copper. Okay, all that's there is aluminum. When you got that aluminum foil right down here, it's just aluminum atoms in that roll of foil. Similar if you've got like something that's made out of copper, all that's in there is copper, okay? So there's just one kind of atom, and we can find these things on the periodic table of the elements, okay? So that's how we know it's an element, pretty good hint. Oxygen is one, of course there's over 100 different elements, okay? So there's only one kind of matter, one kind of atom in an element. Well, another kind of substance is called a compound. And this is when we've got more than one kind of atom present, but you can't necessarily tell it. So a good example here would be the salt shaker. What's inside of it? Salt. Is there anything else in it? No, it's just salt. So there's only one kind of matter, and that matter is salt. But if we were to zoom into salt really, really close, salt is made up of more than one kind of atom. Salt is not on the periodic table. Salt is sodium chloride. NaCl. Okay, so the Na, the sodium, is bonded to the chlorine, Cl, and they make salt. And that's the only thing that's in this salt shaker. We can't tell the Na and the Cl apart. They're bonded together, and they're these little white grains. Okay. Another example would be sugar, which is what this fancy thing is here, C12H22O11. That's sugar. So think about sugar, right? Sugar just looks like sugar. All that's in a bag of sugar is sugar, but technically there's more than one element in that sugar. Okay, so that's a substance. There's one kind of matter, and it looks the same throughout. So now a mixture then, there's more than one substance. They're physically mixed together. Okay, so our first example here is a homogeneous mixture. These ones are kind of hard. So these are mixtures where there's lots of stuff in there, but you can't tell it apart. So one example would be milk. Okay, well, what's in milk? There's like calcium and water and that white stuff, and like there's lots of different kinds of matter in milk, but when you look at a glass of milk, it looks the same throughout. So that's why it's a homogeneous mixture, because this word means like it's all the same. Okay, so the same appearance and consistency throughout, and if it's a liquid like milk, we call this a solution, which just means it's dissolved in water. Okay, so milk is an example of a homogeneous mixture because we have more than one kind of matter that was physically mixed together by the cow's body, and it looks the same throughout. Another thing would be air. We forget about it, but air is not just made of oxygen. It's got nitrogen in there, the carbon dioxide. There's all different kinds of gases in air. But when you look at it, it's just clear. Can you tell where the oxygen is and where the carbon dioxide is? No, but they're there. So because we know that there's more than one gas in there and they're all just kind of jumbled together, it's a mixture. But since we can't tell the different gases apart where they are, this is a homogeneous mixture. Okay. The other kind of mixture we can have is a heterogeneous mixture, and this is where they don't look the same throughout. So you can actually literally see the different bits and pieces. Okay, heterogeneous meaning it's like different. And so like Chex Mix. If you look at Chex Mix, you can see the pretzels, you can see the peanuts, you can see the Chex, you can see the M&Ms. You can actually see the different kinds of matter with your eyes. Soil, right? If you pick up a handful of dirt, it doesn't look the same throughout. There might be little chunks of rock and some little wood pieces and some of this brown stuff and these little specks here and there, and it actually looks different. So there's more than one kind of matter, but you can actually see the more than one kind of matter. Okay? So we have elements, compounds, homogeneous mixtures, and heterogeneous mixtures. So what do you think? This is a glass of water. How would you classify this? Well, in this glass, all there is water. So your hint should be that this is a substance. So now we have to figure out, is it an element or compound? Well, if water is an element, it'd be on the periodic table. And you might not know this yet, but if you look, water is not on the periodic table. It is a compound, right? Because you might have heard of water called H2O, because water is made of hydrogen and oxygen. So we have two different atoms, two different elements making it up. So water would be a compound. Here we have a cup of coffee. Okay. What's this going to be? Well, what is coffee? It's like those coffee grounds, right? And then the coffee beans, yeah, and also water. So we've got more than one kind of matter in this. So automatically we're to a mixture. So now we look and we say, hey, can I see the individual parts, or does it look the same throughout? And this cup of coffee to me looks the same throughout. And so that would mean it is a homogeneous mixture. Here we have some silver earrings. And so this looks like there's just only one kind of matter here. It's just silver. And so that means I'm down to an element or compound. And if I were to check the periodic table, I would see that silver, which is abbreviated Ag, is an element. And so silver is an element. It's the only thing there are silver atoms. And our last example, here we have some delicious Chicago-style pizza from Lou Malnati's, the best deep dish in town. And here we're going to try to figure out, is there more than one matter here? Yes, there's definitely more than one kind of matter. We got crust, we got sauce, we got cheese, we have maybe some pepperoni or some sausage. So we know we've got more than one kind of matter, so it's a mixture. And does it look the same throughout or not? No, it doesn't look the same throughout. You can actually see the crust and the cheese and the tomatoes and all the parts. So that means it's going to be a heterogeneous mixture. So hopefully seeing some of these examples helps you understand some real life applications of how we can classify matter. And we will be doing this together in class. So you'll get some more practice with this too. Here I think is a nice graphic that can kind of help you maybe mentally organize these things if you work better with visuals. This is something that I've done in the past. So it just kind of helps me organize it in my brain. So if this helps you jot it down, great. If it doesn't, then don't worry about it. If you're wanting to read more about this in your book, this is in chapter 2.2 and parts of 2.3.